So sorry about last week. Ran into a few issues not too long before our meeting started, and then I promised you a recording the next day, and life hit me. So I got to thinking on Saturday and Sunday. I was like, well, let's just take the week off, and we'll just pick up where we left off. So hopefully between our first week and this week, you've had time to dive into some of the stuff I posted out on Slack, especially this video. This doesn't really matter about the R data types and objects portion, but this ML semantics portion is really big. And the video kind of starts out with that, talks about the difference in numeric data and nominal data or categorical data. And it really goes through sort of one of the most difficult things about being a newbie in data analytics and data science, and that's really the semantics of things. What are these things called, and what am I reading about, and is it something I already know about and it's just called something different, or is it actually something different that I need to spend a lot of my time on? So we'll go through a little bit of this today, but I'm gonna depend on you to have gone through a little bit of it on your own. So but I'm going to kind of start here with the semantic side of things. What I intend to do with our entire lecture today is go through this, at least half of this data science process in a visual way and a learn by doing way. So hopefully you've got RapidMiner installed and you can work along with me. If not, you can definitely do that from the recording. But what I want to do is at least get to the middle piece of this, which is the EDA portion of it in RapidMiner, with the intent over the next 2 weeks to go all the way through, except this piece of deployment and monitoring. We won't be doing that yet because we're not nearly ready to do that, but at least all the way out here to evaluation within RapidMiner, so you get a visual feel of what this data science process looks like. Once we do that and you're comfortable with it in RapidMiner, we'll change tools. And we're going to take the visual component away from it. And then we'll dive into Python. And that'll probably be in about 2 weeks. So you've got Python pre-work sitting out there from week 1, and you've got RapidMiner stuff sitting out there from week 1. So yeah, just my intention is to get you up to speed on something very visual first. And before I pull that away from you and we switch tools and get into Python. Python and R are really more mainstream tools. RapidMiner was extremely popular about 3 or 4 years ago. They made a few internal decisions that the industry wasn't quite happy with, and that sort of died down a little bit. But over the past 18 months, we've actually seen it begin to get more popular. So as far as tools, visual tools are concerned, it's about number 3 or number 4 on the popularity chart. For data analytics and not data science, it's really, really strong. And I only say that because it does have some limitations on the data science side of things because it is a visual piece of software. It is a running in-memory piece of software, and you need a lot of parts and pieces to really make something happen. When you get out to things like deployment or data engineering, you got to tie into some other things. So there are a few limitations there, but for it being an evaluation copy that you can download for free and use for a year, you can do just about anything in the world you want to do getting up to speed on data analytics. When you move into data science, you really want to be into sort of the world of Python, the world of R, those types of things. If your intent is to stay in data analytics and not go into data science, which is, one sort of being the subset of the other, RapidMiner is fine, Tableau is fine, Power BI is fine. Any of those sort of visual tools for data mining and data modeling will do absolutely everything in the world that you ever need. But as you move out of data analytics and move into data science and get a little bit more into the procedural type of world, you need something with a little bit more heavy lifting like R and or Python. Interestingly enough, RapidMiner will also work with R and or Python, but again, you're just complicating the stack at that point. So anyway, I've also posted on Slack. Let me get this out of the way. Our file that we're going to be using today is called diabetes.csv. If you want to work along with me in RapidMiner, you can download this CSV file, stick it on your desktop so you know where it's at. This is what I'm going to be working through first and foremost, and we're going to start with this actually right now. So let me move LibreOffice over here so we can all take a look at it. If at any time you can't see what's going on my desktop, then just let me know. All right, we don't need that. All right, there it is. Okay. Let me find where I put it. There it is. Okay. So here you go. Let me get Slack back open, or Zoom back open, so I can make sure that I've got the chat open so I can see what's going on in case you need me. So this is one of basically 3 or 4 what we generally refer to as sort of starter data sets for data analytics and data science. And let me kind of tell you what that means. As you're starting out, you go out and you dive into Google, you dive into YouTube, you start looking for resources. I want to be in data analytics. I want to be in data science. Really, you're going to hit tutorials that sort of use 3 or 4 of the exact same tutorials, the exact same data sets over and over and over again. One of those you may have seen already is called IRIS. That's a botanical data set. That's basically a study of 3 different types of iris flowers and their various characteristics, and you're classifying what type of iris flower has what type of physical measurements on their different characteristics of the flower. So it's IRIS. You'll see that a lot, almost more than anything is the IRIS data set. If you've gone out and you've done any of Andrew Ng's work from Stanford, and probably 50% of the other tutorials out there, you've seen the Boston housing data set, which is just a 2 variable data set, one independent and one dependent variable data set that is used to predict housing prices in Boston based on the square footage of houses. Some people will extrapolate from that and actually add other locations. They'll throw zip code into the mix, so, stuff like that, make it a multivariate problem, but that's sort of the second problem. This data set used to run into a lot. It was freely available out on UCI, University of California, Irving's ML repository. So they've since taken it down, but you can get it from just about anywhere else. I pulled it down from Kaggle. It's still a free data set. It's still a historical data set. And basically what it is it's a study of the Pima Indians and the rate at which they have diabetes. And this is for a long time was a very, very popular data set because you can start out with a lot of numbers and this categorical outcome, which is what we're looking for, which is does someone have diabetes or not, based on these other criteria. So that's what we're going to be starting with today because it's pretty straightforward. I don't want to start you with something really T90, small like IRIS. IRIS only got 150 observations and it's only got 5 variables. I wanted to be a little bit more realistic with you. I will tell you up front, this data set is already pretty clean. We'll look at that when we get into RapidMiner and we'll talk about missing data and normalization and different transforms and different things like that. But out of the gate, just know that this one doesn't require a lot of work, and that is a little bit atypical. If you were to go in and just get data from someone, typically it takes a lot of effort, just to get that stuff clean and get it in an environment where you can actually do something with it. but we'll talk about that a little bit more as we go through things. So I've got this in LibreOffice. You can open it in that or Excel on your machine if you want to take a look. And what I wanted to do just right quick is just do a super quick review on sort of the semantics that we're talking about in the video that you watched last time. And I want to break this down into a specific, data analytics problem or a data science problem and sort of get it ready for that. And if we go back and we look at our very first data science process step, it's business objective is what it is. So let's start looking at this from a business objective standpoint and kind of see what we're going to do and where we're going to go, right? So I'm going to actually take this and insert a few rows above it. You don't have to do this. It's all on the recording. Just kind of listen to me. Now, if we take our business objective and we think about it, what we're trying to do is ascertain which of these features, one, many of them, none of them, really contributes to someone having diabetes or not. And that's what the column outcome means. We want to change that to diabetic, where it makes more sense, that's fine too, right? 0 is they do not have diabetes. 1 is they do have diabetes. And you'll see this type of information, by the way, quite often in data sets. You'll see, some type of numerical representation of categories. We're used to seeing something like, like this, yes and no. And that's very typical as well. And knowing how to handle this type of scenario is one of the very first things you learn in data analytics and especially data science, because if you're going to use this data to build a model from, we can't use this type of information. There's no math, no maths that we can do for yes and no. It has to be in a 1 or a 0 format or other numbers. It doesn't have to be just truly binary like that. But you'll find that varies in different tools, and I'll talk about that when we get into RapidMiner. So basically what we want to do is we want to focus heavily on this diabetic column out here. And this is going to be known basically as our outcome. We can also call it our label. We can also call it in statistics, we would call this our Y or our dependent variable. And it's called a dependent variable because its value depends on all these other things. And that's why we call it a dependent variable. So this is sort of the statistics version of it. These two are data science related and machine learning related. But you can see that's four if you want, different titles for the exact same thing. So when you read a tutorial out there, someone may say you have an outcome of such and such, or your label is such and such, or your Y value is such and such, or your dependent variable is such and such. If you're new to your ear, that sounds like 4 completely different things. It's not. They're all the exact same thing. And I know over the years, that's been extremely difficult for a lot of people to wrap their head around, because you're doing a lot of reading, coming up to speed on data analytics and statistics and machine learning and all these different things as far as variables and data types and tools and Python. It's drinking water from a fire hose. So it's good to start out and just think about, okay, well, number one, what am I doing with this problem? Well, I know I want to focus on whether or not someone is diabetic, but I also want to know at the same time, what is the same thing called by different names, okay? So we know this, let me go one more row up. This is actually what we're going to be predicting. We're going to eventually build a predictive model out of this. And some of you might be asking yourself, well, darn, Ben, I've heard you say a lot. I've heard you say data analytics a lot, and I've heard you say data science a lot. what's the difference in those two things? That really is sort of the dividing line between data analytics and data science. It's really whether or not you're building a predictive model. Now, that's my definition of that. You can ask data scientists 100 of them in the same room at the same time, and you're probably going to get 100 different answers. I base that based on my experience between those two. Generally, in data analytics, you're doing a lot of data mining and maybe some modeling, but not for predictive capability. You're generally not using a lot of machine learning. You might use simple decision trees just to unravel data, but you're not using them to actually build and assess a predictive model for deployment to put in a piece of software. So that's generally, again, in my opinion, the dividing line between data analytics and data science. And that gets into sort of that process, right? If I'm doing data analytics, I'm pulling apart the data, I'm mining the data, I'm cleaning the data, I'm trying to gain inference from the data, but I'm not actually modeling it to build a model that I can actually make predictions with. We're going to do that since we're talking about data science here. We're going to do that. We might not get that far today, but by the end of next lecture, we definitely will do that. So this is the column that we're going to be predicting. And let me just make that a different color so you know it's not a title. Okay, so let's look at these other things. So all these other columns over here can actually be referred to by different names as well. Now I'm gonna line these two things up, right? So over here, this one is called the Y, or the dependent variable. These are generally referred to as the X variables or independent variables. So that's how the two are actually related, okay? Something else you will you will often hear these referred to as, and this is a machine learning and a data science term, are features. You'll also, feature space. If all of these make up the left side of this equation, they're generally referred to as a feature space, okay? Something else you will see these referred to as predictors. You'll see a lot in a lot of the machine learning literature out there, it'll say, okay, well, what makes a good predictor? Well, if you're brand new, that sounds like something interesting to you. But what they're really just talking about are the independent variables here. That's it. So three different things here. And again, this is, I'm gonna duplicate myself here, but this is your feature space. Okay, so everything on the left, we're going to be studying. Let's highlight this in our own color. Everything on the left, we're going to be studying to see how it impacts things on the right. We can study combinations of these things. We can study just how they exist on their own. We need to study what units they're in, all sorts of different things. And we're going to get ready to ingest this into RapidMiner so we can start taking a look at that. But let's revisit our business scope before we do that, so we make sure we know what we're talking about and we know where we're going. So we've been asked basically to study these characteristics on the left to see if we can build a predictive model to determine whether or not someone will be diabetic based on these conditions. So this is, at its core, let me give you one more. This is, at its core, a problem that we are going to solve with something called supervised learning. Okay, that is a machine learning term that we use quite often in data science. There are basically three main types of machine learning. You really have supervised learning, you have unsupervised learning, and you have reinforcement learning, Other people would tack on a few other things to that. Some people classify deep learning in its own. Some people classify things as semi-supervised learning. It really, in the old school literature, you really have about three: supervised, unsupervised, and reinforcement. Those are your three. Everything else kind of falls under those things, all right? Now, why is it called supervised learning? Well, it's called supervised learning because we already have data that we're going to work with. In its simplest form, and you may have read some of this in the pre-work articles, in its simplest form, all we're doing is we're using math to build a model of the relationships between these things and each outcome. So every row has some sort of hidden pattern in it that means yes or means no. And we can't see that, obviously. Maybe we can plot it and see it if we have really simple data, but many times we can't. And as the data gets more complicated and gets heavier and heavier, deeper and deeper, that just gets harder and harder for us to do. So that's all we're doing with supervised machine learning is we're allowing an algorithm, we are training an algorithm, and you'll hear that word quite often, to find the relationships between the independent variables and how they are all, how this certain secret combination, if you will, how this relationship means a yes or how this relationship means a no. Okay, so that's really what we're doing, and that's what we're doing with supervised learning. Unsupervised learning is a little different. Unsupervised learning does not have this column that we can predict. It does not have a dependent variable. It's just a bucket of data that you are trying to divide into certain groups, if you will, or certain clusters. And then reinforcement learning gets out to something totally different. That's an optimization problem that you give a bounded space to, and it tries to optimally solve something that you can't do on your own. So, but we're going to stick with supervised learning for pretty much everything that we do in this workshop. So, okay, enough talking. Let's get to it. So that's the semantics. That should get you everything you need. You know what? While we're here, let's talk about one other quick thing. Two different data types, right? And we'll probably just stick with those two. Obviously, numbers, and I don't care that they have a decimal in them. When we get into Python, you'll see that there's a difference. But for our discussion today, we have numbers, and then we have things that are not numbers. These are often called, let me move this over just a hair so you can see it. In RapidMiner, you have numbers or integers, and then you have binomial or multi-binomial data. Basically, these are numbers, 1, 2, 3. These are categories like red, green, blue. These do not have a quantitative value, right? And remember I told you we're just using math to do all this stuff. Well, how do I get a value to these things? We're going to talk about that when we get into RapidMiner. But for now, just know we basically have numbers and we have categories. Those are the two things that we're really, really dealing with, okay? We'll get into sort of the nuances of how that impacts something in supervised learning here in just a few minutes. Okay, moving over to RapidMiner. Let me find real BNC. Okay, somebody stick in the chat whether or not you can see that okay. Is that everybody cool? Okay, fantastic. All right, we're done with this for now, so I can minimize this. So this is RapidMiner. So really, really cool piece of software. Like I said, it's a strong piece of software, and it's free unless you want to go out and use it on a professional basis. When you start it for the first time, it sort of looks like this, And you've got this choice of whether to do a blank process, something called turbo prep, or something called auto model. For those of you that are brand new to this, stay away from these two. Okay, this is kind of what got RapidMiner in trouble last time. This is an auto model process that basically you stick your data in and out comes the other end. It's a big machine learning model, and if you need to change it in any way, you got to lift the hood and unplug all the wires. And I highly suggest staying away from these two things. Don't as a new person, don't even get involved with them, because they're push button type stuff, and you're not going to learn what you need. You'll get to the end of a problem, you just don't know how you got there. Okay, and then you certainly can't fix it. A couple things to know: there's a Learn tab here. RapidMiner has a fantastic set of tutorials built into the software. So you can literally start here under the Get Started tab and work these first 8 tutorials, probably do it in a couple hours. They're extremely valuable tutorials from the aspect of, if you're a new person to this and you need a visual way of seeing what some of these semantic terms mean, those first 8 are fantastic. We have, when we were using RapidMiner in the data science program at UT, these are the first 2 or 3 that we actually started out with, because we used to have an entire course in RapidMiner at the very beginning of that program. So again, if you want to dive deeper into it, there it is. Today, we're just going to start with a blank process. Okay. So let me give you the nickel tour of what RapidMiner, all these things in RapidMiner right quick before we dive into the data, because we've got about half an hour left. So over here on the left, this is just your repo area. This is just where you're going to store stuff. Think of this as, if you're on Windows, think of this as File Manager, right? This is where you're kind of keeping yourself organized. You can store processes, you can save files, you can save data, all these different things. This local repo is actually stored on your machine, and you can actually, dive into kind of where that's. You can see here's the physical location of it on my Windows machine. You can move that around if you need to, or if you need to go to your file manager or to terminal and actually make a copy of something, that's where you would find it. Also, any connections that you've made to something like APIs, or maybe you've got developer connections to Twitter or something like that. All that is stored there, and RapidMiner do all that stuff for you. Processes. This is basically what RapidMiner calls a file. So you're going to be doing everything in a visual way out here on this stage. You see, it's actually called process. So, and when you want to get to a point and you save something, it's actually called a process. So it goes right here in this process folder. And then of course you've got a folder out here for data if you want to do something specifically with different CSV files or whatever format you have it in. And then if you need to tie it to a database, maybe you're using SQL, or maybe you're making a JSON call, or whatever it is, to whatever type of database, you've got an actual repo section for that. So you've got database connections there if you want. So that's kind of your data window, if you will, and where you save stuff, if you will. We'll be using this import data function button right here in just a few minutes. So know that that's always there as well. The heart, the lifeblood of everything in RapidMiner is actually not code. We'll be doing that in a couple of weeks. Remember, I told you RapidMiner is very visual. Everything in RapidMiner has an operator. So when I want to do something like retrieve a file from the cloud, I can go here to cloud storage. I grab retrieve and I drag it out here to the processes, and it turns into this little box. So there's an operator for almost everything in data science, and you can even build custom operators if you want. So know that that's where we're going to get most of our stuff from as far as operational aspects of what we're going to be doing today. They'll either come from this operators window or they'll come from down here. And I'll tell you what this is in just a minute. You can also get more operators from the marketplace. There are tons of free operators. You can go over to top downloads and take a look. You got operators for web mining, for text processing, for Python scripting, in database processing. You can do deep learning, you can do text analytics, all these things. And this is just in the top downloads, right? Some of these are free, some of these you can purchase for little to nothing, and they go right into the side of RapidMiner, and then they'll show up here in your operators section. So great marketplace. It's grown tremendously over the years, and very, very well supported. So this spot in the middle, like I said, this is going to be your process area. There are three things you need to note about this. There's an input side, and there's a results side. See these little tiny nodes here? Here's input, and here's result, okay? When you build a process on this stage, you're basically going to connect operators together. And then the last operator will always be connected here to your result, because then you run this process. We're going to do this together in a few minutes, okay? So that's kind of the two main pieces of this stage. The other one's down here at the bottom. If you're just opening RapidMiner for the first time, yours might say activate wisdom of the crowds. Go ahead and do that. Basically, what that means is RapidMiner is crowdsourcing the next predicted step for you. So if someone, let's just say someone comes over here and they bring in the iris data set like that, okay? Then what RapidMiner is now telling you down here, 39% of everybody that uses this operator, not this data set, but 39% of everyone using RapidMiner that retrieves data is using the select attributes operator next. So I can drag that out. Then it tells me, okay, 44% of everyone that uses the select attributes operator uses the set role operator next. So this is, this is very strong for, for starters, because many times you're really not sure about what to do next. RapidMiner is recommending, based on other people that are using RapidMiner and have used RapidMiner, it's actually telling you, hey, look, this is probably what you should do next, because this is what most people do. That is extremely strong. And that's why I like using RapidMiner for someone that's brand new to the process, because it has that wisdom of the crowds functionality in it. And you really just can't get that anywhere else. And for someone, remember, we're trying to sort of replicate, this process. Until you nail this down and you understand what's involved in each one of these little small boxes, having some, recommended input really, really helps. So that's wisdom of the crowd. So we've got input, we've got result, we've got wisdom of the crowd. This will change from time to time. It will change from a process window to another type of window that we probably won't get into today. But just know that you can go back and forth between this window and other windows up here at the top. So if you drop data into this and it dumps you over to results, all of a sudden you panic and it's gone, just go back to design up here, and that'll take you back to this window, okay? Okay, two more, and then we're gonna get our hands dirty. As you bring operators out, we'll bring Iris back out. As you bring operators out, this window changes. This window shows you the parameters of each operator that has been selected. So you can see I'm not selecting that operator now. So I've just got, basically, these are the parameters for just my project. If I go over here and I click on this operator, it only has one parameter, and that's actually this, the location of the file. If I bring select attributes in and I select that particular operator, you see it has a different set of parameters. So for those of you that are going through the UT program, this is not the exact same thing as hyperparameters that you would be tuning of a model in a model, but this is where it would show up, okay? So right now they're just calling parameters the options that go along with these operators. Remember, you're not using any code, so you've got to, you can't just say select attributes. You've got to know, okay, well, which attributes do I need? Okay, well, here you go. There they all are. These are the attributes that are in the data set itself, the columns that are in the data set itself. And remember, we've split those up into independent variables and dependent variables. RapidMiner doesn't know that. So somewhere along the line, you're going to have to tell it, these are independent variables, and this is a dependent variable, okay? So we'll do all that with operators and the parameters. The last but not least, down here on the bottom, RapidMiner has one of the best help features I've ever seen. So you can see here, if I go to select attributes, the help window actually changes to select attributes. It's got a nice little synopsis on it here. If you need to know how to use it, it's even got a tutorial built in. Now, when you click on this, it's going to move away from your file and open this tutorial for you. So just be wary of that. But it's got a great description. It's got different examples of how to do other things with select attributes. It's got the inputs. It's got the outputs. It's got everything you'd see here in the parameters. Everything you ever need is right here in this help menu. Just keep in mind, it is dependent on what is selected on the screen. So if I click off of select attributes, it goes back to process. Okay. So that's most of it. It's a simple piece of software. It's one of the reasons it's very popular. It's also one of the reasons I love using it for beginning students. You can go as far as you want to in data analytics, and really as far as you want to in data science. You'll hit a brick wall before it's over with. As your data gets much bigger, you'll have to tie this into the cloud or into a DB or cloud resources or something like that. Just because either you need more horsepower or you need to pull the data down, from another source. Things tend to slow down at that point a little bit, but you can absolutely, create an EC2 resource and and build a bridge between this and that if you wanted to. So, but at some point in time, you kind of run out of leg room with RapidMiner. Now, for anybody on this call, that probably won't happen for you until you're absolutely ready to move to something like Python or R. And even then, you're still working on your machine, right? We'll get to a point where we leave our machine altogether. We'll go out to Amazon, GCP, or Azure, and we'll be doing all of our work out there in the cloud. And then we don't have many limitations anymore. We've got unlimited horsepower practically. It's just, how much do you want to pay? That's kind of what it is. So let's dive into to the diabetes data set. So I'm going to go over here to import data. Let me go and look for my diabetes data set. I think I put mine on the desktop. So I've got to go out here and find it. So when you select your data the first time, RapidMiner does a really good job of stepping you through this. So kind of watch what's going on here. So there's my diabetes CSV file. I'm going to click next. And it doesn't look like a lot happened other than it's just summarizing what you see on the screen, but that's not the case. There's a lot that's happening here. So number one, I can turn off whether or not the first row actually has titles on it. A lot of times you get a CSV file and that very first row is a header row and has titles on it. Sometimes you have that, sometimes you don't, right? In our case, we do, and we want to use that first row as a header row. And then we want to tell RapidMiner, okay, that first row is a header row, so start on the next row when you're importing the data. This is a CSV file, so it is comma separated. Most of these other things can stay the same, but I can tell you, if you get a file that does not look right in this preview, and it does have problems down here, you notice that RapidMiner is telling me there are no problems with the import. Usually it's your quotes or your skip comments that needs to be on or off. So those are the two things that, and that's just the way that a CSV file has been generated, that's all. CSV files are just simple text files with a comma between separating every single piece of data. That's all a CSV file is. And they can be generated by a lot of different means. So sometimes you have comments in it, sometimes you have quotes in there. Somebody sticks a paragraph or someone's name or a statement in a CSV file. Maybe it has quotes around it from how they copy pasted it or something like that. So sometimes you got to be careful how that looks. But RapidMiner is telling us there are no problems. So we're going to go to next. Now, this is a really important screen. So let's take our time and let's kind of walk through this. Number one, you see it says no problems. That's great, but let's just don't dive in. Let's kind of take a look for a minute, okay? Because we've got some very important things happening. My dogs are just a bark, sorry. Oh, they didn't. The FedEx man got away scot-free. So a lot of things are happening on the screen. I want to make sure you see what's going on. Many tools will try to interpret what data type a certain column is for you. When you bring data into Python, it'll absolutely do that for you. It says, okay, well, these are numbers. This should be numbers. This is a string. It should be a string. Maybe it's a category, and I'm gonna make it an object. You know, it's doing its best to take the data in, and there's nothing cognitive about it. It just basically says, okay, well, this is a number, and it fits a data type of a number. I'm gonna assign it as that. R does this as well, or RStudio does this, not R. But RapidMiner certainly does that. So you can see it's taking the pregnancies column, which is full of numbers, and it's assigning it as an integer, which is just a number, right? And that's fine. That's what we want it to be. Same thing with glucose, same thing with blood pressure, skin thickness, insulin, BMI, this diabetes pedigree function, age, all these things should be numbers. At this point, don't worry about whether they're real or whether they're an integer. All those things are just numbers, right? You can get out here to the right a little bit more, and we see age here as well, but here's the one we want to think about a little bit more. Outcome, yes, it is an integer. Yes, it is a 1 or a 0. But in reality, in the real world, in our business scope of things, that's not a number. That's a yes or a no problem. Okay? So I want you to hear this and take a note on it. This, in supervised learning, when you have a category, don't worry about how it's represented. It's a category. When you have a category in the dependent variable in supervised learning, this is called a classification problem. Okay, and that's another piece of business requirements we need to think about. So now we know we're using supervised learning. We know outcome is our independent variable, and we know that it's a classification problem because this actually isn't, it is a number in the real world sense of things, but it's a representation of a category, even though it's a number. Okay, now I'm going to throw you for a big loop here. So just hear me out for a second. Because we aren't only going to be using RapidMiner in this discussion, we're going to be using Python, we're going to be using RStudio and R. These tools work differently. RStudio and R and RapidMiner have the ability to actually categorize something as an actual category. But that's just human facing. That's just for our business requirements. So I can go in here and I'm going to tell this, I don't want it to be an integer. I want it to be, in this case, binominal. Polynomial is just more than 2 classes in this. We have a 0 and a 1, so we only need binominal, okay? Now, why did I do that? Because some tools like RapidMiner and like RStudio need to know that the dependent variable is a category versus a number because the algorithms are different. Okay? Just know that in the background processes that you don't see, that outcome is still a number. And I'll tell you that because when we move into Python, which is in a couple weeks, and we do the same process again, everything has to be a number. Everything. If I brought outcome in and had yes and no there instead of 1 and 0, I've got to convert that yes and no to 1s and 0s. Everything has to be a number. But that's the advantage of using tools like this, that you have the benefit of actually building a categorical feature or a categorical dependent variable into this. Okay. Now, the tools will separate the way machine learning algorithms work based on whether or not this dependent variable is a category or a number. So that's why here we have to make it a category. We don't have to do it here. We can actually do it out on the stage if we want, but it's great to just go ahead and do it here. And now you know everything is in the in sort of the, you know, the everything is in the manner that it needs to be in. You've got numbers and you've got a category. And this is a supervised learning problem and it's a classification problem. Okay, so we're ready to go. Go to next. All right, all it's asking you now is where you want to store the data. So I'm gonna put it in my local repo. I'm gonna call it diabetes. I'm just gonna leave everything as default. I can click the little checkered flag here. Now, you notice the stage is gone, right? The very first thing that RapidMiner does is it shows you what the data looks like. And it builds this little new tab up here called example set. Okay, it's not splitting the data or dividing the data or anything like that. This is just the raw data. That's what it is. So you can take a look at it if you want and get an idea of that everything is okay. And 9 times out of 10, everything is perfectly fine here. What I want you to pay attention to is the next step in this process. Now that we're finished with a business objective, we understand what we're doing here. We understand what we're going to eventually predict, and we understand why we're doing it. We've moved past data requirement. We've moved past data collection. We didn't have to go out and get this from a database or pull it out of Amazon S3 or Snowflake or any of that kind of stuff. We just had a simple CSV file, right? We're going to move into this last step that we're going to start working on today called exploratory data analysis. Now, between these two pieces, there's something that's very important that's typically sort of tucked in this data collection and data requirement area. It's not listed here, and I want to make you aware of it because in most data science processes it is, but they just kind of tuck it under these. It's something called pre-processing. What we actually just did was a lot of pre-processing. We changed data types. We verified that there were no problems in the data set. I don't know if you caught it, and I should have pointed it out to you, but in the actual process of bringing in, it told us there were no missing data. There were no missing values. All those things generally occur in pre-processing. We can handle that on the stage as well to check for things, but I wanted you to know because I want you to know there's a lot more to what we just did when you're using something like Python or R. RapidMiner makes it simple. RapidMiner makes it really fast and does a lot of the heavy lifting for you. But if anybody's on the phone can attest, that is much more difficult in something like Python. But you'll get to the point to where it's just as easy. Just for a beginner, it takes a lot more time to do what we just did in other languages and in other tools. So I don't want you to think that, oh my gosh, this is really quick. There's a big, probably 60, 70% of the work that you do in data analytics and data science revolves around these two areas. It just does. Data's a mess when you get it, it generally is. But we're using RapidMiner. We've kind of gone through this. Now let's take a look at this EDA. This is where you're going to gain most of your knowledge about what you're working on. As data scientists, a lot of times we don't have a lot of domain knowledge about what we're working on, unless we're, part of a team and is dedicated to a certain company or something like that. But sometimes, especially for consulting, we don't have that. Sometimes we've been assigned an expert to help us. Sometimes we're kind of tucked in under a subcontracting process for months or something like that. But in any case, we have this process called EDA for short, and it helps us gain knowledge about the data. Now, that's not just from a domain perspective. We need to gain as much knowledge about this data so we can see what we need to do to it to get it ready for this piece, for this modeling piece. But that's not all we're doing. There's a ton of knowledge that comes out of EDA. And remember, I told you when we first started today, that's kind of the splitting point, if you will, between data analytics and data scientists, right? Our data science roles is sort of this EDA portion. If I'm in data analytics, I'm doing a heck of a lot of EDA because I'm gaining tons of knowledge from pulling this data apart, but my end game is not the same. as if I were doing that for data science. My end game in EDA is generally there to not only pull the data apart and gain a bunch of knowledge out of it from it, but it's also to begin selecting the optimal features for the data science process or the modeling process that comes next. That's kind of the end of EDA. So not only am I pulling the data apart to gain a bunch of knowledge about it, I'm also trying to do my best to develop an optimal feature space. Remember let me see if I've got LibreOffice still open over here. Remember we've got this thing called a feature space, right? And we've got all these variables on the left side. Well, I mean, what says we need to use all these things? Is there a way we can actually reduce the dimensionality of this side of the equation? In data science, the end of EDA helps us make those decisions. But we've got to gain a lot of knowledge about what we're dealing with before we actually get to that point, okay? So the way we do that is through two different tools. One, statistics, and the other, visualizations. So let's take a quick look at just some of the statistics and visualization tools in RapidMiner, and then we'll get a little bit deeper into setting up this problem on RapidMiner, and we'll stop for the day, okay? So there are basically 2 or 3 different types or big buckets of statistics and the way we use statistics in data analytics or data science, okay? We study variables by themselves, or we study variables and the way that they interact with other variables, okay? One of those, if you're studying just a variable by itself, and when I say variable, just a column by itself, that's univariate analysis, just one variable. If I want to study 2 or more, that's multivariate analysis. And RapidMiner is really good, sort of out the box, about showing you everything there is to know about each individual variable in this file. And it's generating these small histograms, which is just showing you the frequency of occurrence of each one of these numeric variables. And you can open them up and kind of take a look at them like this if you want. And this is the statistics tab. There's also other portions of statistics that are really, really important for us to know. Whether it's univariate or multivariate doesn't matter here. But what we're studying are things like the minimum, the maximum, the average amount of this numeric variable, the standard deviation. How much does it actually move from its mean, if you will, okay? These are all really important things in statistics, and they tell us a story about what we're looking at, right? You can see just from looking at these simple visualizations, you know, if you look at the pregnancies out here on the left, you can see whatever's happening here in pregnancies occurs a lot more often, you know, to the left than it does the right. If you look at glucose, whatever is happening here at glucose occurs a lot more often in the middle of the pack. Certainly with blood pressure too, it's kind of the middle to the right. Skin thickness is skewed more to the left. Insulin is more to the left. BMI is really centered kind of in the middle of things, right? What we're really looking for, just at a very brief level here, is how much do these things differ from one another? If we've got the awesome advantage of all of these independent variables sort of looking like glucose, you see how glucose is almost symmetrical here? I can open it up and we can take a look at it. You can see how it's almost symmetrical. You can almost see the bell curve riding over the top of that, right? If it was symmetrical like that or somewhat symmetrical like that, we generally refer to that as a normal distribution, which means the bulk of the data is sitting just stacked right around the mean. There's some calculations about defining what a normal deviation is that you can get into in statistics, but for now we're just doing this visually. You know, what we're really wanting is we're wanting to identify these features that are sort of normal, not because we're going to just, hey, we're just going to only use those, but we want to differ identify the differences between something like this and something like pregnancies that is stacked heavily to the left, and then something down here like insulin that's stacked to the left, and pedigree function that's stacked to the left. Age even is stacked to the left. These are not things that are common, that are occurring in the same manner across this entire distribution of values. And that's what we're looking for here in univariate analysis, because if you get something that is extremely skewed to the left or extremely skewed to the right, you may have to handle that. You may have to transform that feature, or a model. When you go to use machine learning, algorithm may look at that and go, wow, that is way out of whack compared to what these other things are. I need to really focus on it. And it may over prioritize the training probability that actually assigns to that particular feature, when in reality, it shouldn't be doing that. So we're really trying to build sort of a roadmap, because remember, down the road, we're going to be modeling. So we look at these univariate charts as far as histograms are concerned, and we're really just making a note of things. If something's way, way out of whack, we may have to actually transform that data, which we're totally allowed to do. We're not changing something permanently when we transform it. We are masking it so a model treats it like we want it to be treated. We can always undo that. We can take the inverse of that on the other side if we want to. So basically, we're building the proper roadmap for a model, if you will. So anyway, that's your univariate analysis. And you can come all the way down here. You can see whether it's an integer or it's a category, it's still giving you a histogram. Just in this case, it's showing you basically two, if you will, the counts of zeros and the counts of ones. I can open visualizations and show you what that looks like. Okay. All right. So that's your statistics tab. Okay. And this is sort of your central tendencies, if you will, for statistics, is what this is showing. Okay. Take a quick dive into visualizations, and then we're going to spend about 5 or 10 minutes setting up the rest of this and get it ready for our conversation next week. So right out the gate, obviously this is set up for univariate analysis, but what if I wanted to do something like multivariate analysis? I won't dive into why we use which of these charts. You can certainly do that on your own, but just know we'll use histograms and we'll use scatter plots probably most often, in addition to bar plots. We'll do those. But scatter plots will compare one or more features or one or more variables to one another. Okay, so if we go to scatter here, we say, all right, in the x-axis, we want to study blood pressure. And in the actual, sorry here, we want to study, let me move one of these over. What did I say first? Blood pressure. Let's say we want to study blood pressure, and we want to study how it compares to insulin. You can see here, we've got blood pressure and insulin in the same actual scatter plot, which is really cool. You can see as someone's blood pressure rises, right, how insulin, the amount of insulin that's in their body, is actually reactive to that. Okay. Maybe insulin's not the best one. Let's look. Blood pressure and BMI is probably two pretty cool things to see together, right? So you can see as someone's BMI increases, or as someone's body mass index actually is increasing, right, their blood pressure is actually higher too. So you can see those two things are directly related. You want to throw a third in here. We can go out here and let's say we've got color. Let's say we do that by age. Okay, so now you can see here, and we'll have to fix that for BMI as well. But you can see it's the blood pressure itself is categorized by age. You can also, if you want to adjust the jitter a little bit, that kind of adds a tolerance to the observations, because obviously you can't see all of them stacked up on top of each other with a zero jitter like this. So let's take age back out of the equation here, and we'll increase jitter just a little so you can begin to see there actually there are some other pieces down here that are probably faulty from the survey. But anyway, that gives you an idea of some of the capabilities of visualization. This is a study in its own. If you really are interested in doing something in data analytics itself and just stopping there and not moving on into data science, EDA, statistics, and visualizations, those are your three big areas. And you can take entire classes on just visualizations. The outside of that is something that you really can't take a lot of classes on. It's something you have to develop over time, and that's storytelling, right? How do I put all this stuff together and tell a story with it? If I don't know anything, if I'm a non-technical audience, I don't know what this means. It's not very helpful to me, right? So I have to figure out how to convince someone that what they're seeing is what they're seeing. So anyway, let's dive back into this view right quick. And if y'all are okay, we're going to run a few minutes over, but if you need to go and go back to work, if you're at lunch or something like that, don't hesitate to, and I'm going to post a recording in the morning when it's ready anyway. So I want to get you set up and ready for our conversation next week, which is probably going to move us into modeling. So the first thing I'm going to do now that I've got diabetes ready and I've checked all of my features, I've gone through my EDA, I've decided, okay, we'll get into this next week. We'll get into sort of using correlation and deciding what features should stay and what features should go. For now, my business scope tells me I'm just going to use everything because we're starting and we're just trying to get to something successful at this point, right? So I'm going to use my whole data set. I'm going to bring it in. There's my diabetes data set. Now, if I want, I can literally just go from my output here, click on it, and drag up to result. You see how the two are connected? Now this is a process. This is a finished process. Now I can run this, and it's just going to show me the output of what that is, which is just the data. Okay? But again, I want to do more than this, okay? You notice I've also got a new results output port up here too. I've got a secondary one here. So I'm going to get rid of that. So what is the wisdom of the crowds? What is that telling me down here? Well, that's telling me your next recommended operator is probably select attributes. So we're going to bring that out, and I'm going to space these out a little bit purposely so you can see them. You notice this one's got an EXA input tab on it. Example attribute is what that stands for, EXA. And you notice it's red and it's gray. It's meant to be hooked to the output of this one. You notice I'm mousing over that output and the little vignettes popping up. That's showing me what the output of that operator is. If I go over here, you see there is no output because it's not connected to anything yet. So what I'm going to do is I'm going to connect this one to this one. And by the way, I don't know if you noticed the error. It's telling you basically, hey, Jack, nothing's connected to me. So that goes away once I hook these two together. And now, if I go over here to the examples out, I see the same thing that I would have had on the retrieve diabetes data set output tab. I see the same little vignette. So what we're actually trying to do here is decide what our feature space looks like. Remember, we had this concept of this feature space. What are these? Which one of these columns are we going to keep? And which one of these are we going to get rid of? Well, we can do a little more due diligence back in our EDA step, and we can make some decisions about which ones we're going to get rid of and which ones we're going to keep. For today's exercise, we're going to keep them all because I'm walking you through kind of how to do this. Next week, we'll probably backtrack a little bit. We'll dive into using some statistics and some transforms, and we'll decide which one of these to keep, which one of these to get rid of, and then we'll transform the ones we actually want to keep. For now, we're just going to keep them all. So up here in the parameters, we can just choose all. If we wanted to choose a subset, which we'll do next week, we can go to subset and we can select which one of these attributes we want to keep. Now, this is extremely valuable because when you're model building, you can actually go back. You can build a model, see what it looks like, see how, assess it, see how well it did. You can actually, if you don't like it, go back to this in the process and take away and add features on the fly, and then go back and build your model again. For anybody that's ever done that by hand, you just had a heart attack because that's really fast if you just leave that in play. So we're going to select the attributes. The next thing we're going to do, wisdom of the crowd tells us, is set the role. Now, something we haven't done yet, if we go back over and we look at our data, we just selected our feature space. Okay, but actually if you look closer in RapidMiner, we actually selected all of these in RapidMiner. One of those, and I'll show you what, if you go back over here and you look at all, and you go to a little vignette, you can see they're all selected. Get it out here on the end here. You can see all of them are actually selected in the vignette, including diabetes. One of those has to be a dependent variable. We know that. We have to have X's and we have to have a Y. We have to have features and we have to have a dependent variable. We have to have independent variables and we have to have a dependent variable. RapidMiner calls the dependent variable roles. Okay, it calls other things role too. But for now, set role means which one of these things, which one of these attributes are you going to assign a specific role? So we're going to connect the examples here, and we're going to go into set role, and we're going to choose our outcome, and we're going to assign it to, guess what? Label. Okay, if we hop back over to this, okay, we renamed this column, don't forget it, okay? There's the word label right there. So that's what we actually want to assign that. It becomes a label. That is what you've just done to set this up as a supervised learning classification problem. Okay? There are tons of things we did not do in here, and there are things we did not do in here for today's exercise. But it was super important for you to get the semantics down of what we're dealing with. Next week, where we'll pick up where we left off, we'll do some more formal EDA, and we will make some decisions about which one of the features to keep, which one of the features to get rid of. And we'll go ahead and build this all the way out into not a predictive model, but an actual model that we can see, and we can use it for making inference. And that will further help you understand, oh, here's the difference in data analytics and data science. Okay, for now, we're right here in the middle of this data science process. We'll back up, we'll do some more EDA next week. We'll do some specific feature selection. Might talk a little bit about feature engineering. Probably we won't do it because the data set's not big enough or not complicated enough, and we know a lot about this stuff. And we'll actually do some of this modeling, just not for a predictive. We won't get into machine learning itself until we get into, we make that jump into data science, which is probably going to be in probably 2 weeks. So we'll get you there as soon as possible. Okay, folks, we're going to stop it there, just in respect of time today. I'll get the Zoom recording here in a bit, get it processed, probably tomorrow before I stick it out on Slack. I'll put some other information for you on Slack as far as what we're going to be doing next week. Please dive into RapidMiner and get at least this far along. Now that you're there, you can just go here to save, select your processes. We'll call this SUP class 1. Supervised learning classification 1. And now it's ready to go. You can see here it's in my processes as subclass 1. Now I can close down RapidMiner. I can open it right back up and it'll be sitting there waiting for me. I don't have to bring the data in. I don't have to do anything. It's all ready to rock. So we'll pick up right here next week, and we'll move right on into the rest of EDA. We'll move right on into feature selection, right on into building our first model, data modeling, not predictive modeling. And then who knows, maybe we'll get far enough next week to get into our first algorithm. So thanks everybody for a fantastic day today. Again, apologies about last week. Sometimes those things can't be helped, But please, if you need anything from me in the interim, I'll certainly be around. Catch me on Slack and look for some other things to be posted on Slack as well. Have a great day, everybody.